All right, let's dive into something pretty cool today.
Okay, sounds good.
Deep learning, but with a twist.
Hmm.
Imagine teaching a computer to, say, recognize faces,
Uh-huh.
but not by programming in every little detail, but
Yeah.
by having it learn from tons of examples. That's deep learning
Yeah.
in a nutshell.
Right.
But then, what if we could make it even smarter?
Okay.
And that's what we're going to be talking about today.
Oh.
Looking at a research paper
Okay.
that uses something called support vector machines, or
All right. Yeah.
SVMs,
Yeah.
to boost the accuracy
Mhm.
of these deep learning models.
Yeah, it's a fascinating approach, definitely.
So it's kind of like giving these models a superpower upgrade.
You can think about it like that, yeah.
Okay.
So you see deep
Yeah.
learning models, they typically use something called a softmax layer to make
Yeah.
decisions.
Okay.
And it's kind of like the model is saying, okay, based on what I've learned,
Yeah.
I think there's like a 70% chance this image is a cat.
It's a 20% chance it's a dog, and so on. Right.
So it's all about probabilities with softmax.
Probabilities, exactly.
Okay.
Yeah.
But then this research paper, they're like, let's shake things up
Yeah.
and replace softmax with an SVM.
Right.
So what makes SVMs so special?
Well, SVMs, they're really good at drawing those clear boundaries
Okay.
between different categories.
Right.
So imagine you're sorting M&Ms
Okay.
by color.
Yeah,
Right.
I like M&Ms.
Yeah, so an SVM would basically figure out the
Mhm.
perfect dividing lines
Yeah.
to separate the reds, blues, greens, and so on with the maximum space between each group.
Okay.
So there's no mix-up.
Okay, so no more M&Ms getting mixed up.
Exactly.
Gotcha. So
Yeah.
instead of just estimating probabilities,
Yeah.
the SVM is kind of like making a clear-cut decision,
Yes.
which could lead to better accuracy.
Gotcha.
So they basically took deep learning, combined it with this SVM approach,
Yes.
and called it DLSVM. Yeah, deep learning with support vector machines.
Okay, so
A mouthful, I know.
DLSVM.
Yeah.
Okay.
Yeah.
And they basically took the feature learning power of deep learning,
Yes.
combined it with the sharp decision-making
Exact.
of SVMs.
Yes, it's like a dynamic duo.
Dynamic duo. I like that.
Yeah.
Okay, so before we get too far ahead, let's just back up a little bit
All right.
and just talk about deep learning itself.
Okay, sure.
Just a quick refresher for our listeners.
Yeah.
It uses these things called neural networks,
Right.
which, from what I understand, are kind of like digital versions
Yeah, that's a great way to put it.
of the neurons in our brain.
Yeah.
So these neural networks,
Yeah.
they're made up of layers and layers of interconnected nodes.
Yes.
It's kind of like this complex web.
Yeah, it's like a network where each node is kind of processing information,
Okay.
passing it on to the next one,
Yeah.
refining the understanding as it goes along.
And then when it comes to image recognition,
Yeah.
a super popular type of deep learning model is the CNN.
Yes, convolutional neural network, right?
Right. So
Yeah, they're really good at picking up on those patterns and images.
Yeah.
So that's why they're so good for like identifying objects and faces.
Okay, so to put it all together, we
Yeah.
have these deep learning models.
Yes.
Oftentimes CNNs.
Yes.
Learning from tons of images.
Mm-hmm.
And traditionally, they use that softmax layer
Yes.
to make predictions.
Exactly.
But now
Yeah.
we have this DLSVM approach
Right.
that swaps out softmax for an SVM,
Swaps it out. Yeah.
which potentially leads to even better accuracy.
Exactly.
Uh,
And you might be wondering, did it actually work?
Yeah, did this DLSVM actually live up to the hype?
Did it deliver?
Did it deliver?
Yeah, so the researchers put it to the test
Okay.
using 3 different data sets,
Okay.
and the results were pretty impressive.
All right, hit us with the results.
Okay, so first up,
Yeah.
they tackled facial expression recognition using a data set from a challenging competition.
Okay.
And get this,
Yeah.
DLSVM achieved an accuracy of 71.2%,
Yeah.
which not only beat the other methods in the competition,
Okay.
but actually surpassed estimated human performance.
Wait, hold on.
Yeah.
You're telling me a machine
I am.
was better at reading human emotions
Yes.
than actual humans?
It seems that way.
Wow.
Yeah, it is quite remarkable.
That's both amazing and slightly unnerving.
I know, right?
Okay.
So this model that did that was a CNN with an L2 SVM as the final decision maker.
Okay.
And it's important to note that this particular task, recognizing these subtle facial expressions,
Yeah.
it's something that humans often struggle with.
Right.
So for a machine to actually outperform us on this is
Yeah.
a pretty big deal.
That is a big deal.
Yeah.
Okay, so DLSVM is 1 for 1.
1 for 1?
Okay.
What about the other data sets?
What about the other ones? Yeah.
How did it fare?
Yeah, how'd it do?
Okay, so next, they tested it on the MNIOS data set,
Okay.
which is this, like, classic benchmark for
Hmm.
recognizing handwritten digits.
Okay.
And even with a relatively simple model, DLSVM achieved an error rate of just 0.87%.
Wow.
Which is incredibly low.
Even without a super complex model,
right?
It still got really good results.
Really good, yes.
Impressive. What about the third data set?
The third data set was CFAR-10, which is all about classifying images of objects like airplanes, dogs, cats, all those things. While DLSVM didn't get, like, the absolute best result ever recorded on CFAR-10, it still showed significant improvement over using the traditional softmax approach.
Okay, so across all three data sets, we're seeing DLSVM showing its potential for making deep learning even more accurate.
More accurate, yeah.
I'm curious, what's the secret sauce here?
That's a great question.
Is it just that SVMs are better at, like, fine-tuning the model? Or is there something more fundamental about the way that they work?
That's a great question. So the researchers, they actually investigated this by evaluating the DLSVM model using the old softmax objective. And even then, it still performed well.
Really?
Which suggests that the SVM loss function itself plays a crucial role in improving accuracy.
So it's not just about, like, tweaking the settings. It's like the SVM approach fundamentally changes how it's doing things.
It fundamentally changes the game, yeah.
Yeah, like it's a completely different playbook.
Yeah.
But we're getting a better outcome.
A better outcome, yeah.
Okay. This is all really fascinating stuff.
Yeah.
But I want to shift gears for a second.
Okay.
For those of us who don't spend our days building deep learning models, why should we care about a slightly better image classifier?
That's a fantastic question.
What's the big deal?
So here's why this is so important, okay?
Okay.
These advances in deep learning, especially with techniques like DLSVM, have the potential to revolutionize so many different fields.
Okay.
We're talking healthcare, transportation, so much more.
Give us some examples.
Okay, so imagine medical imaging systems that are even better at detecting diseases.
Okay.
Maybe even in their earliest stages.
Wow.
Think about self-driving cars that can navigate these complex environments with even greater safety and reliability.
Wow. Okay.
These are just a few examples of how DLSVM could make a real difference.
So we're not just talking about, like, incremental improvements.
No.
We're talking about potential breakthroughs.
Breakthroughs, yeah.
With far-reaching consequences.
Yeah, and it's not limited to just image recognition.
Oh, okay.
The principles behind DLSVM could be applied to other areas of machine learning.
Like what?
Like natural language processing or even financial modeling.
So the possibilities are really quite vast.
Possibilities are vast.
Wow, it's a lot to process.
I know, it's exciting.
It seems like we're just at the beginning of understanding the full potential of this.
The full potential, yeah.
But I'm sure our listeners are eager to learn even more.
Yeah.
Where can they go to dive deeper into this topic?
The research paper itself is a great place to start.
Okay.
The authors have made their code and model parameters available online.
Oh, cool.
So anyone who's got the technical know-how can experiment with DLSVM themselves.
So for those of us who aren't ready to dive into the code just yet, there's tons of resources available online.
Oh, yeah.
We're going to uncover a fascinating detail about the specific type of SVM that the researchers chose. And why it's so special, so stay tuned.
I'm intrigued. Welcome back. Remember how we mentioned the researchers used a specific type of SVM called the L2 SVM?
Oh, yeah, the L2.
It turns out this wasn't just a random choice.
Okay, I'm intrigued. So what's the story behind this L2 SVM?
Well, the L2 SVM, it actually...
This sounds like something out of a sci-fi movie.
I know, right?
L2 SVM.
But it's not from a sci-fi movie.
Okay.
It's got a pretty interesting history, actually.
Oh, okay.
The L2 SVM was actually proposed several years before the more common SVM formulation we know today.
Oh, wow. So they kind of dusted off a vintage SVM.
Yeah, you could say that.
And realized it was a perfect match.
Yeah, they're like, hey, this works really well.
For modern deep learning.
Yeah, exactly.
That's pretty cool. Yeah. So what makes the L2 SVM so special?
Remember how we talked about SVMs drawing those clear boundaries between categories?
Yeah.
The L2 SVM kind of takes that concept to the next level.
Okay.
It's incredibly sensitive to errors.
Oh, yeah.
Meaning it really, really wants to find the absolute best dividing lines to prevent anything from being misclassified.
So if a regular SVM is a judge at a talent show, the L2 SVM is like Simon Cowell.
Yes. That's a great analogy.
The super strict judge who's like, no, do it better.
You've got to be the best.
Yeah, really pushes those contestants to be their absolute best.
Absolutely.
Okay, I like that analogy.
And this emphasis on accuracy, right? It's especially important in areas where mistakes can have, serious consequences.
Right, yeah.
Like medical diagnoses or self-driving cars.
You wouldn't want an AI making life or death decisions.
Right, exactly.
If it wasn't sure.
Exactly.
Yeah, that makes total sense.
So DLSVM, with its L2 SVM, seems perfectly suited for these high-stakes applications.
High stakes, all right.
Yeah, and it's worth noting that research in this area, it's still ongoing, right? There's so much more to discover about how deep learning and SVMs can work together to solve complex problems.
Yeah, it feels like we're just scratching the surface.
Just scratching the surface.
Of what's possible.
Yeah.
So for our listeners who are feeling inspired to explore this further, what are some key takeaways?
Some key takeaways, okay.
That they should keep in mind?
Okay, the first takeaway, I would say, is don't be afraid to think outside the box.
Okay.
Right? The researchers here, they didn't just stick with the usual approach.
Yeah.
They combined techniques from different areas of machine learning and achieved some pretty remarkable results.
It's like that saying, if you always do what you've always done, you'll always get what you've always gotten.
Exactly.
So sometimes you have to try something new.
You got to step outside the box.
To really get those big innovations.
Exactly.
I like that.
The second takeaway, I would say...
Okay, what's number 2?
Is all about paying attention to the details.
Oh, okay.
Even seemingly small changes, like swapping out that softmax layer for an SVM, can lead to significant improvement.
Right.
Sometimes the key to success lies in those subtle but important tweaks.
Okay, so attention to detail is crucial.
Pure attention to detail,
What else should our listeners remember?
This research really highlights the importance of understanding the underlying principles of the techniques you're using.
Gotcha.
Don't just blindly apply algorithms. Take the time to learn how they work and why those choices are made.
It's kind of like trying to cook a gourmet meal.
Okay.
But you don't understand the basics of cooking.
Right.
You might be able to follow a recipe.
Yeah.
But you won't really grasp
you won't get it.
The nuance and the technique.
The nuance, exactly.
Right.
In machine learning, a solid foundation in the core concepts is essential.
Especially if you're building systems that make critical decisions.
Especially then.
Yeah, you need to be able to explain why those decisions are being made.
Exactly.
And be confident.
And be confident, yes.
In their accuracy.
Yeah.
Okay, so we've got think outside the box.
Yes.
Pay attention to the details. Understand those underlying principles.
Yes.
What's number 4?
So the fourth one is more of a question than a piece of advice, actually.
Okay. I like where this is going.
The researchers focused on image classification in this paper.
Right.
But I'm curious, what other applications could benefit from this?
Okay, yeah. What other areas are ripe for this kind of innovation?
Well, natural language processing is one that immediately comes to mind.
Okay.
Imagine using DLSVM to improve tasks, like sentiment analysis or machine translation.
So like chatbots that could have more nuanced conversations.
Exactly.
That could be really powerful.
Really powerful. And another area that's particularly exciting to me is medical diagnosis.
Okay.
Imagine systems that can analyze medical images, patient records, genetic data to identify diseases earlier and with greater accuracy.
That could really revolutionize healthcare.
It could really revolutionize things. And
what other applications are you thinking about?
We could even apply DLSVM to financial modeling.
Okay.
Think about using it to predict stock prices.
Oh, interesting.
Assess risk, or even detect fraudulent activity.
So the possibilities really are quite vast.
They're vast, and as more researchers kind of delve into this potential of DLSVM, I'm confident we're going to see even more creative and impactful applications emerge.
This is really just a glimpse, into the future of what's possible with intelligent machines.
I know, it's exciting.
It's definitely an exciting time to be following the advancements in AI.
Yeah.
But before we get too carried away with all the potential applications,
you're right.
Let's bring it back down to the present.
Okay, back down to earth.
For our listeners who are wondering, like, how to apply this knowledge?
Right. How do we make this practical?
What advice do you have for them?
I think it's important to just start with a sense of curiosity.
Okay.
And a willingness to explore.
Yeah.
Even if you're not a computer scientist or a mathematician, there are plenty of ways to engage with this field.
Right. And there's tons of online resources.
Oh, yeah.
From introductory courses to more in-depth tutorials.
Absolutely. And remember, the field of machine learning, it's constantly evolving, right? It's not just about learning the current state of things, but also developing a mindset of continuous learning.
Yeah, continuous learning and exploration.
Absolutely.
Stay curious.
Stay curious, that's the key.
Yeah.
Always be open to new ideas and discoveries.
Yeah. Who knows, maybe one of our listeners.
I know, right?
Will be the next to make a groundbreaking breakthrough in AI.
That would be awesome.
That would be amazing.
I would love that.
Okay, so as we approach the end of our deep dive, let's shift our focus to a fascinating aspect of this research paper that often gets overlooked. It's publication date.
Publication date, yeah.
Time travel alert.
I know, right?
What's so special about the publication date?
Well, this paper was actually published back in 2013.
Wow, that's over a decade ago.
I know.
It's amazing to think that research from that long ago is still relevant today.
It really is.
And still insightful.
Yeah, it speaks to the, foundational nature of this concept and the ongoing quest to improve machine learning techniques.
It makes you wonder what other gems are hidden
in
the archives of all these research papers. Just waiting to be rediscovered.
Waiting to be unearthed.
Yeah.
I love that.
So to our listeners who are now feeling inspired to dive into the world of machine learning, where should they start?
I would say start with that spark of curiosity, right?
Okay.
Don't be intimidated by the technical jargon or the complexity.
Yeah.
There are so many resources available, from online courses to interactive tutorials that can really break down these ideas.
Yeah. And you don't have to be a math whiz or a coding guru.
No, not at all.
To grasp the fundamentals.
Yeah. There are even podcasts like ours that aim to make these topics approachable and engaging for everyone.
The key is to find what works best for you.
Exactly.
And your learning style.
Yeah. And remember, it's a journey, not a race.
Yeah.
Take your time, ask questions.
Ask those questions.
And most importantly, have fun along the way.
Have fun.
Yeah.
Okay, I like that.
Learning should be enjoyable.
Yes.
And when it comes to a field like machine learning that's so dynamic and rapidly evolving, that sense of curiosity and wonder will take you far.
Yeah.
Who knows?
Yeah.
Maybe one of our listeners will be the next to make a groundbreaking discovery in AI.
That's a fantastic thought.
I love that.
Okay, well, on that note,
yeah,
I think it's time for us to wrap up this deep dive.
Yeah, all right.
We covered a lot of ground today.
We did.
From the basics of deep learning to the intricacies of support vector machines.
Yes.
And the remarkable results of combining them with DLSVM.
It's powerful stuff.
We've explored how this research, even though it's over a decade old, is still relevant today.
Still relevant.
And how these core principles can be applied to all sorts of fields.
There's so many fields.
From image recognition to natural language processing.
Yes.
And beyond.
And beyond.
But perhaps the most important takeaway is the reminder that innovation often comes from thinking outside the box.
Outside the box.
Revisiting those old ideas. And staying curious about the world around us.
Absolutely.
So to our listeners, keep exploring, keep learning.
Keep learning.
And keep pushing the boundaries of what's possible.
Push those boundaries.
And never underestimate the power of a simple question.
Yes. A simple what if.
Beautifully said.
I like that.
Thanks for joining us.
Yes, thank you.
On this incredible journey into the world of DLSVM.
It's been fun.
Until next time.
Yeah.
Keep those minds engaged.
Keep them engaged.
And those questions flowing.
Let those questions flow.